Hi everyone. So as mentioned in the last part of Module 5, there is an class activity. Um, we were just in the process of setting up the files on the server and in touch with the IT or the HPC team to fix some issues. So now things should be working out. I'm going to invite you all to make sure you go through this exercise. Go through the steps because from now on you would expect that we will go through some practice and through the online or through the resources we have from NEU, for example, the on-demand cluster and so on and so forth. So I'm sharing my screen here. What you can see is if I go to modules and then you go to module D, if you remember that, I'm hoping everyone sorted out their access, at least tried it once. So if you feel comfortable to go here, you are new to things like terminal, you would follow these steps and try to get interactive session and then be able to access and run the command through the terminal or some computation resources that are made access to you through some graphical user interface. So it's more maybe friendly way for some of you. Personally, I'm going to show you my preferred way. So let's see. Okay, so here we go. So once I click here, you would log in using your own Northeastern resources. I'm going to click on Interactive Apps Up, and then there's XFCE Desktop Beta. Once I click here, it's asking me for what resources I would need. Okay, so partition, data, if I need GPU or not, all of these decisions are going to impact how long it's going to take to release these resources for me. So in other words, this is kind of a request to ask for computational resources. Imagine now your own personal computer, it's not enough with the resources that you would like to use. And so you would ask for another server. You would try to request resources from another server. These are some basic specs. But again, this is a virtual setup of another computer that you have access to. Now, at the beginning, if this is your first time to have a client server type of access, it might be a little bit confusing for you because everything you are doing is on your own screen. So you might think, oh, you get confused. Am I doing it on my end or another end? But always remember, getting an access to a supercomputer or computer resources happens generally in this way. You will not go to access to the building there. That's a very secure, protected building with fire safety, and so that they usually call data centers, where you have the actual physical computers there. So the way we access these resources happens through virtual ways. So this is one way. Okay, you can indicate if you need an email or not as a notification once this is assigned to you. So as you see here, it is queued now, meaning it is under processing. Your request is under processing. So I don't think it's going to take long time. We can wait a little bit. Every now and then make some update, or perhaps it's going to be updated automatically. And then what is going to happen is we will have access to a virtual desktop that will give you the terminal feature, very powerful resource that I'm going to speak about shortly. So let's wait a little bit here. Let me make some refresh. So it is still queued. Let me leave it again a little bit. Until this is happening, let me explain. On my screen, this is a Mac system, as you can tell from here. Mac is itself a Linux-based operating system. Here we go. So we have it now. It's up and running. So let's access that. Let's launch the desktop. Again, imagine this as another computer that you are able to access. And so here you go. So you have a full working online system. I can click here and then ask for the terminal emulator. So now this is where you run some of the commands that are needed in the in-class activity and exercise. So what I'm going to show you on my end, because I'm going to shift to Mac here, and if you go to Mac, which is originally built over Linux system, terminal is integrated and it has been always there as part of the operating system. So I'm going to write terminal and then directly you get it. So I open now, this is the terminal on my end. Oh, okay, let me clean it here, clear. And so this is the terminal. It is on my own, I am still on my own personal computer, okay? But terminal is a program. So it may have this, dark background, but again, you can make some changes depending on the software. So you can, go ahead and if you wish, do some changes for this window and features, change the colors, whatever makes you more comfortable, okay? But the point here is this terminal is a program, although it doesn't have a fancy graphical user interface, it understands many of the instructions that we can write. So it has its own parser, it has its own system to run and execute the commands that we are gonna type here, okay? So we'll come to this. But anyway, whatever I'm gonna do here is something you can do here. If it happens, I believe Windows should have recently some emulators for a terminal program and writing bash script. But if it happens that you don't have that access, you can go ahead and ask for these resources online. And then once you get this, imagine this is your own personal computer through the on-demand service. And then from there, you can go and run your own service. Now, keep in mind that we asked only for 1 hour. You could have asked for more. So depending on the task that you will do. I'm going to come to this later on. So let me delete these resources. I don't need it. Let me stop sharing here and basically go ahead and share our terminal. Okay, very nice. So this is the terminal here. Again, you see this terminal is a very wonderful software in terms of what it can do. So when I write clear and understand to clear the whole thing, okay? So if you go to the exercise page, so let me just quickly share my screen. Make sure you know where's the exercise, okay? So if I go here under assignments, there is the assignment on module 5 assignment. And then there is week 05.html. This is the part that I need you to check and go through. Make sure you read this, okay? You may have some questions, especially if it's your first time. Again, it's a new experience, but it is very good training for any bioinformatician. Okay, so this is the tutorial you go through. I tried to skim through certain parts, and then what I hope is that you go and run these instructions here, and it shouldn't be a difficult thing to do, okay? So we will be working with the program to read some FASTQ files that I explained in the module 5 recordings, and then compute some quality scores. And one of my treasure hunt questions were related actually to how we compute quality. Sorry. Okay, how to compute quality score for one full read if we know how to get the quality score for a single nucleotide, and then get the GC content, which is just counting the GC numbers of guanines and cytosines, and computer percentage for that. Okay, so let's do this. So I'm gonna share again my terminal here. Okay, so here we go. So the first thing I need to do, and again, whatever I'm doing here, if you are on access on the on-demand resources, you would do the same thing. Okay, so whatever commands I write, even starting with SSH, okay, this is how we access the servers in use. So this is login discovery. That's the name of the server. It's discovery. You know, think about tens or hundreds. It's a big computation resource. It's a server, set of servers, high performance computing resources, whatever term you want to use to explain this. There is a physical space for that, hosting lots of computers, CPUs, and lots of computational power. So what I'm going to do is I'm going to access this whole system through what's called the login node. Okay, this is a way to establish communication. So it's like I want to scan my ID and access that physical room. Once I access that physical room, it is easier for me to communicate and ask to get one of the resources available to be assigned. So when I access now, I'm basically going to the cluster, okay, what we call a cluster. So we are not supposed to run and execute commands directly, okay? So SSH, let's establish a communication here. It's going to ask me for my password. Let me get this here, okay. Okay. So here we go. So this is a message from the research computing team. It tells me that I'm connected to the discovery cluster. So it identified my username and my password successfully. And again, we can run some instructions here that are basic in terms of interacting with the folders and so, but we shouldn't run heavy programs. And why? And something I'm emphasizing again, and it is emphasized in the tutorial. You have to understand a little bit about the architecture and what's happening. When I log in here, what is this here? This is actually an existing system on some server. And this server is login coordination system, meaning it is this access point server that hundreds of users may be accessing at the same time. All what is meant to do is to organize our access, and then we will make a request for specific resources so that we can run some of our scripts and commands, our heavy computing. We're not supposed here to go and run an actual program. You'll get a complaint from the system, you'll get a complaint maybe from the Ars research computing team, and so on and so forth. You yourself will end up complaining because these resources are not unlimited. They will be limited in terms of computational capacity and memory. Again, it's perhaps your first time. All what you need to do is once you are here, understand that yes, you have access, you successfully access the cluster now, you are into the room, but yet you don't have a resource that you can use. So what should we do is actually, once we establish this, is before I jump and ask for some resources, I want to make clear here and then see that we have, okay, we have LC home and then my directory here, okay? So inside my directory, I have desktop, VNC, and some folders, okay? So this is my local folder. The folder that we'll be working with is gonna be CD under courses, okay? And this is by and course 6310, okay, and 224. So this is the folder that we're going to look into. It's under courses. And when I say CD, it means change directory. Gradually, you would learn some of these commands. If you are into, I want to understand why LS means listing, CD means change directory. You'll pick up these commands as you keep working with the terminal. But if you are into, knowing what commands should I use, there are lots and lots of commands. Okay, very powerful system. All of these programs are like LS itself is a program. CD itself is a program. So all of these are programs to do specific tasks. Very powerful programs and very efficient. So you can look into what's called bash scripting, and then usually these are called Linux boot camps. So if you have a short course in campus or online that you want to watch, it's going to introduce you to a set of these commands. So for now, let's change the directory and see the structure of the folder that we'll be working with. So here you go. We have data folder, shared space, and for staff and students. You should have your folder in students. Check your folder in students, and then it should be predicted where other users cannot access it. So if I say change directory to staff, since I'm staff, and then I'm going to put my username, I will end up now in my own directory. It's not under the home directory, it is under the course directory. So under course directory, we have our own files. Okay, let me actually remove this for now, and so it is going to be clean. Nothing is listed here in this space as of now. Now, few things I want to share with you quickly. Oops. So those are the instructors of the course. We have the data folder here. It is read only. So it's meant only to be offer for us some data files like FASTQ files that we can use to work with. Okay. Now, if I run some command, like try to know the space here, it tells me that there is 1.4 terabyte data available. Now, when you work with any cluster-based system, you need to go through the documentation and understand the storage system there and get and ask these questions. Where should I, if I need to store my data? You'll always be, informed about the following. Do you want to store your data temporarily or permanently? And always, if you say temporarily, it means you have lots of space you can use, okay? If you say permanently, you have a very limited space that you can use. Right now, I guess like each user have, I guess it is in the tutorial somewhere, okay? You can also still go through the documentation. Let me see if okay, you can save up to 75 gigabytes in your own home directory. Okay, so again, if I go cd home Soufan, remember now there are two folders of Soufan. Soufan under home and Soufan under the course directory. So these are two separate directories. Okay, so if I go there and say, it's telling me, okay, now you see there are 34 terabytes available. Now these are for all users, but I have my own quota. My own quota is only going to be 75 gigabytes. Okay. Now, if I go to another resource, which is Scratch, oops, I shouldn't have done listing. There will be lots of folders and files. This is an open space. It's temporary for only 28 days. Only 28 days that you can store information here. Okay. 28 days that I'm writing here is not an instruction. It's not something the system's typing up just as part of the tutorial so that you can read it. So about 28 days, your data can stay here. So make sure it's not, to understand, it's not a permanent place to store your data. So if I run this command to know what's there in terms of storage, it is unbelievable, right? So it's 2.5 betabytes. So Scratch is huge. So you start to see this. Certain spaces, you have 100 terabytes. Now you have in betabytes. Betabytes, which is temporary. Every 28 days, they do cleaning. So yes, it's huge. So when you have any cluster anywhere in the world, they will try to push you because the resources are always limited. So when you deal with these things and you are doing a task in this course, which requires saving some files, make sure you understand this. You don't want to end up saving lots and lots of files of the middle steps, in one specific location for a very long time. Okay, so make sure always you kind of maintain this, manage this, so you have all your data saved, accessible, and then once you get the final results, that's dealing with the raw data is something we can discuss in the office hours if you're interested, because again, we need to make sure if we have data that we have spent on some budget, we want to make it available there forever, right? But anyway, now as a cluster-based thing, we have to understand the system. We have some resources that will be available for us almost forever, depending on the architecture. But for now, what I want you to understand is that I'm not clicking any icons, that by just doing cd, which means shifting between different directories, I'm accessing not only a different directory, but a different hard drive on the system. So this is one way that you can think about it. Okay. Now, what else I want you to see is that we are going to request for some resources, computational resources, okay, because we are on the login node. We want to go on the compute node, okay. So here what I'm going to do is, let me clear this. So I'm going to say srun. So this is, the system here has a scheduler, its own scheduler. And again, I am now going to request from the login node to communicate with the whole system and assign for me some actual computational resources. I'm going to ask for 16 gigabyte for 3 hours. Actually, I don't need 4 hours, and I don't need 16 gigabytes. 8 gigabytes is fine. And partition courses, okay. And I want directly to access the bash script side. So if I request this now, I click enter, it's telling me wait. Sometimes you may wait long, sometimes you may, you know, as now, as you see now, directly I got the resources allocated. Now for you, it may still seem the terminal, okay, nothing changed, but I'm not anymore on the login node. You see login -00, this is C0758. I've actually moved from one computer to other computer, from the first computer where I shouldn't run any actual code or program to the place where I can run actual codes and programs, okay? This is not the only way to access the terminal through this instruction. I can run a bash script. I can actually ask allocation for hundreds of servers for my tasks, something we may look into in the future. For now, I am inside my Scratch this allocation, C0758. So this has changed, guys. Okay, you see this? This has changed. So make sure you notice this, because again, I'm trying to refresh my my history in my mind right now, like what it used to be for me the first time I saw the terminal, maybe, I don't know, 15 years ago or more. And again, it's sometimes confusing. I'm on the same position on my own local personal computer, and still I'm accessing multiple computers. Yes, this is the power of a network that is linked to high performance computing resources. So now I've been allocated some nice resources. Okay, I don't want to be here. Oh, oops, let me clear this. Let me go back. So if I click the arrows, like the up arrow, I can go back in the history, okay, and see the commands that I need, or I can type history and see the commands that you know, I've used. So I don't remember this perfectly, so I'm going to copy CD. I don't, you know, make sure I get to the same folder. So now I'm back to this folder. Now I am gonna move, well, one thing I will go to, which is data, ls, CD qualities, and GC content. Now we have 3 files. We have FASTQ files, one for forward and one for reverse read, and this is st.py. It's the program that we are gonna run. So let me open r1.fastq file, and this is the file here, okay? So it has a group of reads, okay? I can do something like grab the plus sign, sort of, or add, and know how many reads we have here. Oops. Okay. Let me say, I guess I should say -c. Okay. 60,000 reads roughly. It's not a big file, okay? If I want to see the size of these files, so I know that this is kind of 16 megabytes, is nothing, okay, for sequence files. Okay, fine. What is the st.python file? So I'm gonna skim through it, okay? This is a program that's gonna write the list, read the list of input files, or the files that we give to, okay? So we have some arguments that we can give the parameters, okay? By default, is going to retrieve the information for one read, okay? Feel free to play with that. I'm going to show you an example of a working code. Now, the main functions here, it's going to read the FASTQ files, and then it will try to go through the Fred score that we have discussed before, get the base calling probability, base call probability, get that probability, okay, using the encoding, some, take the ASCII code -33, get the value, get the probability, and then we end up with this score. Eventually, you can take the sum of all quality scores for the whole sequence and then divide by the length. And this is how we can get the average quality. And also we can run another output and get the GC content, which is the number of G's and C's divided by all the accounts. So very simple program. And there might be different ways or more efficient ways to do it. For now, what I want to do is we want to run this program, but it's not preferable to run it here because this is under data folder. Data folder is only read. So what I would do, I would go to my own folder. Okay. So yeah, sometimes, let me go back. So when I say cd staff, I put O dot, so I don't want to keep typing my name. So I can say tap, okay, tap, and then there are two names that start with O. So if I put S, I put tap, it directly continues, tap, okay. So we are here, nothing locally in my site here. So what we want to do is few things, okay. First of all, let's get the program that we are interested in working with, okay. Okay, I will do this, yes. So let me copy this st.py file to here, okay? So now I have st.py file. So I've copied this program from there. I keep the files there, the data files, it is fine. Now I want to run this Python program. So what should I do? Should I write Python, st.py? No, this is not the preferred way. Why? Because for each Python program, we usually need some libraries. Look into this. So you need to import some libraries. You may end up sometimes, like here, all seems generally basic libraries, so it's no big deal. But sometimes we will see that we have libraries that we need to install. On this server, although we have access to it, we have some freedom to work with it. It's not flexible to the extent that we can do what? It's not flexible to the extent that we can install any of our programs. We have to coordinate this with the administrators of the system. So usually we don't install our packages except locally. One of the good approaches or protocols to do this is to set up our own environment, okay, locally. So what I'm going to do is I'm going to load some program. This is Moduload Miniconda 3. This is the version of the software. It's Miniconda. Now, what's Moduload? This is almost like saying, go online, download Miniconda, zip file, unzip that, install it on the whole system, make all the necessary setup, and then give me access to it. It's already, this has been already done for this software. It's already set up. I just need to call it. So my environment in this specific node, compute node now, this one would be aware of it. So once I say this, okay, it has been loaded. Now what I want to do, these are some conda commands. So I'm going to activate the environment, and then I'm going to create my own environment, okay? This is that we're called Bioinformatics 6310, okay? I'll say yes for everything in terms of answer questions that we may receive. And now, let me clear this. And now I'm gonna say activate. So I've created this environment, okay? I want to activate it. So now I am inside this environment. So two things. I'm inside C0753, and this is the environment now. What does the environment mean? It means anything that I'm going to store here is not going to break or overlap with the system installed packages. In other words, I can install Python 3 here or 2, and the system could have a fully different version. It doesn't matter. So here, feel free to install or do anything you want, okay? In this case, our environment is activated. So all what I want to do is define a path, okay? So let me first do it this way. Okay, so I'm going to call the program, and then I need to give it the FASTQ file. So this is under courses. Cool. Data quality. And then what files do I have? Okay, starts with apes, and then here you go. I give it this file, I get this output, and so you get these numbers indicating it gives you us for the first read, it's giving us the quality and the GC content. Okay, so quality score and the GC content. Okay, now if I put this here, okay, this is the program that we're getting. Let me go down. Okay, so it's going to give first the GC content in order and then the average quality score. Okay, so the GC content is 46% of this read is GCs, and 38 is the quality score of the read. Now we can pass to it a parameter n. So let's try this. Run the same program, pass to it -n as an argument, and say 2 reads instead of 1. And so now I get the information for 2 reads. Here you go. So that's it for now. The only thing, if you are bored of typing this whole all the time, this whole path every now and then, you can actually define a local path variable. Local path variable. Okay, and now what I do is I'm going to say, well, Python, Python -3, and then I'll use a $, FASTQ path, which means take this whole value. Okay, that's what we call variable for this terminal right now. Just give it the file name. Okay, and now we get this read. So what I'm going to do, I'm going to exit now from the compute node. I am back to my login node, and to complete my, exit, I'm going to put another exit, and here you go. I am back to my own personal computer. So I hope you can go through this tutorial and submit the necessary assignment.